Hi everyone, welcome back to my YouTube channel. First of all, if you are new to this channel or if you haven't subscribed, do consider subscribing my channel. So today's problem is trapping rainwater. So as usual, first of all, we'll be understanding the problem statement and the logic part, right? And then we'll be understanding the code part as well. You can follow me on other platforms as well. The link is there in the description and you can consider subscribing my channel for more such content. Okay, so this is a very famous problem, right, and has been repeatedly asked in multiple interviews. So we will understand the problem statement first. Given n non-negative integers representing an elevation map where the width of each bar is 1, compute how much water it can trap after raining. So we are having n non-negative. They have clearly specified non-negative integers we do have, and the width is given as 1. So we have to determine how much water can be trapped after raining. So this is, you can understand with the help of this simple picture, the figure that they have provided, and we are having the height. We are having the height of each bar, you can say each bar height we are having. So we have determined that okay, in these boxes, in these bars, how much water can be trapped. So for here, if you will understand with the help of this picture, so here you can see we are having the first bar height of 0, then bar height of 1, then again bar is of height 0, then again there is a bar of height 2. So between a bar of height 0 and between a bar of height 1, water can be trapped, and one more thing logically to think, that how much water can be trapped if one bar is of length 1, one bar is of length 1 and one bar is of length 2. So how much water can be trapped? This much only, depending on the minimum bar. Relatable question we did yesterday also, so that will also help. If you haven't solved it, make sure to solve this, then come to this question for solving, right? And width we are already having. So how much water can be trapped? 1, you can say 1 water is trapped here, right? So width is given to us, right? That is already 1. So for trapping or consider the area occupied, we need height and width only. Width is given, that is 1 only. Okay, so likewise that's how like we have to proceed ahead. Then we are having a bar of height 2, then a bar of height 1, then again a bar of height 0, then 1, then 3. Then you can see, if you will see here, so we are having here a bar of height 2 and then a bar of height 3, right? So between this bar of height 2 and between this bar of height 3, there are multiple bars of different height that has occurred. So how we will be determining, okay, what is the, so here, from here, if you will see, so first there was a bar of height 1, and the maximum bar that we have seen is like from the left, that is 2, and from the right, that is 3. So obviously the minimum one we are going to consider, so 2, and the current bar height is what? 1. So 2 minus 1, we got 1. And from here also you will see this bar is of height 0, so 0, and the minimum bar from 2 and 3 is what? 2. So 2 minus 0, we will get 2, and again a bar of height 1 here, you can see. So obviously the bar that we're going to consider is 2. 2 minus current bar height is what? 1. So 2 minus 1, that is 1. So overall how much water here? 1, 2, and this 2, 4. 4, and overall this one also, if you will include, that has occurred before, so 5. And likewise, if you will proceed ahead, so here also some water will be trapped, that is 1. So overall 6. So 6 will be the output for this particular 6 units of rainwater are being trapped. You can refer the image also for this. One more thing, guys, just by watching the video, just by listening what I'm mentioning, if you think that you will be able to understand the problem and you will be able to solve it, it's not gonna work. Take a copy pen, what I'm saying, just do a dry run of the same. Okay, this is how, just that will help you, that okay, how this is actually working. Just by watching the video, it's not going to help. Probably you will get some understanding and you will code it up, solve the question, but anyhow it is not going to help, right? You won't be getting the understanding. I am sure about it. If anyone is saying that maybe they have a sharp mind or whatsoever, but I won't be able to understand, honestly. So take a copy pen, do a dry run. Okay, this is how the things are working, this is how the water being trapped, right? So take a copy pen and do it right now, right? So constant being provided. Okay, so I hope the problem statement is clear to you. Problem statement is clear to you. Now comes the logic part, that how we'll be solving this problem, right? So when I was explaining you the problem, that okay, this is how the water being trapped and what it would be depending on if there is a bar of height 3, a bar of height 2, or a bar of height 3. So between that, obviously it depends. It was sort of depending on the bar which we have seen from left, the maximum height bar which we have seen from left, and the maximum height bar which we have seen from right, and out of them also maximum one from the left and maximum one from the right, and and between, and from them also we have to choose the minimum bar, minimum height bar, right? Minimum height bar, right? Minimum one we have to choose. And on top of that, what would be involved, that we have got the max from left, right? Take the minimum from that, and whatever the current bar length is. So if let's say from the left you have got 2, from the right you have got 3. So out of 2 and 3, which is minimum? 2. And the current bar length is 0. So 2 minus 0 means it can store 2 units of water, right? Getting my point? So okay, one thing you can think of is that what we can do is that we can do the pre-computation. Pre-computation of what? Pre-computation of storing the maximum amount of water at a particular ith index, or at a particular ith instance, from the left side and from the right side. We can do the pre-computation. Like what I actually mean is that is, I hope my screen is visible. So here you can see this is our array, right? So do the pre-computation. So here first, this is for left max we are storing. Like we are storing that okay, at this particular index, this is the left max we have seen till now. Then this is the max. This is the max. This is how we are updating. So first we have seen 0. So 0 is here, right? Then we have seen 1. So obviously 1 is greater than that of 0. So value will be updated. Then 0 is not, will be like max will still remain the 1 only. Then we have seen, so 2. Then we have seen, but it won't be updated because max is 2. Here also 2 will remain. Here also 2 will remain. Now the updated maximum would be 3, and that's how we will store the values in the left max array. Right now we have to do the same thing for right. From right also we need the maximum one. So right max array that we have pre-computed. So from the right, the first value that we have got is 1. Then we have got is 2. Then 1 is there, but obviously maximum is 2, right? So that's how we have computed. So we have now arrays for left and right that has been pre-computed. So now our work is done. So what we have to do is that simply what we can do is that now we'll be simply as of now, just ignore this part. Now what we'll be doing? So in our answer, what we'll be having, we have to obviously choose the minimum from at a particular ith index. What is the minimum from max of left of I and right of I? So minimum we have to take, and we have to subtract the height of the current bar, and that we have to add in the answer, right? So we'll be getting our answer, and that we are going to return, right? So that's what. Now if talking about, see here we have taken 2 arrays. So somehow can we further optimize it? So you must be thinking, okay, I mean, we have solved sort of problems, similar kind of problems previously also. So instead of having 2 arrays, I mean, we can optimize it in what way? That okay, let's compute left array only. Means we are having the array which is pre-computed, having the maximum for the left part, like from the ith instance, what is the maximum values that we have seen, we are having that in the left array, right? And dynamically at the same time, when we are calculating the answer, we can have a pointer, we can have a right max variable, we can have a right max pointer that will be updated, right? Instead of having a separate proper right max array, we can do this, right? So that's what we are doing here is that, so in this way what will happen that we will have just one array instead of having two arrays that we were using, right? So here what we are doing is that we are updating the right max value as per like whatever is the value in right max, if that is maximum, or height of I. So I is what, n minus 1. So or height of n minus 1 is maximum. This print statement I added because I I was checking on something, right? And okay, if I remove this, so yeah, now this time instead of having right I, we will have right max. So right I was mentioning, so at the time you have to just simply update here like I equal to 0, I less than n. Okay, this thing also you have to update at the time when you are having left and right array maintained, right? Because now because at that time we are just having ith, like what would be the maximum for a given index I from left and right. So you can just simply use this part. But okay, I forgot to specify that. But as of now, we are like dynamically computing this right max part. So we'll be starting our iteration from the right hand side, right? So this is all the sort of optimization that you can do, right? But now is it a possibility that we can do this in constant space, that we are not even using that left, or you can calculate any one array before, like you can calculate left array or right array, it's up to you. So is there a possibility that we are solving this problem with the constant space without taking either left or right array? Like are you able to think of any such approach? Well, yes. So we can solve this using two pointer approach. Again, the same topic that we are currently going through. And this is, let me tell you, this is the last problem from our topic, two pointer approach. Like some of the standard problems were there, so they have been covered, right? So again, so we'll be maintaining two pointers, left and right, and two again this left max and right max to have the, because we need the max values we need, right? So left and max as of now initialize with the 0 0, and this is our answer. So we will continue in the loop till the time left value is less than that of right. Now, so the game is all about having the first thing is the minimum height out of the left and the right. So from there we will start our iteration part. So here what we are checking, if height of left, if it is less than equal to or height of right, so what we will do, first we will compute the left max. So whatever is the value, or whatever is the value as of now of the height left, whatever is the maximum, keep this in left max and calculate the answer as answer plus equal to left max minus height of left, right? And that's how we will update the value of left. Now see, I'm just telling you the logic, I'm just telling you that how it is working, but I'm 100% sure watching the video is not going to help you. You got some idea? Take a copy pen, do a dry run, write the pseudocode, okay, how this is, and do a dry run. So even I myself have done this. You can see I have added those printed statements, and then I also did like, okay, how this is exactly the things going on. So please, otherwise you won't be able to understand and you will be like, okay, I'm not getting it. So take a copy pen, again repeating, and do a dry run of the approach, right? So what we will do, like here see this printed statement is there. So initially if you will check here, left max would be 0, everything would be 0, right? Then we will start. So 0 and 1. First pointer is at 0 and then the last pointer is at 1. What is the minimum? 0 1 is the minimum. So we will get into this if condition. Left max will be updated with 1, and answer. So in answer, what is the value of left max? 1. And on what we are on, current bar height is also 1. So 1 minus 1, obviously 0 will get nothing, what is going to be stored, and left value will be updated, right? So now we are at 0. So again 0 is what? 0 is less than that of 1, the value which is pointing to the right one. So we will again get into this if condition only, and left max will still remain 1 only, because obviously 0 is not greater than that of 1, right? And again we will calculate the answer. So what is the maximum value that we have seen? So 1. and current value 0. So 1 minus 0, so answer would be 1, means 1 unit of water is being stored. Then we will proceed ahead. Then this time we have 2, this time we have 2. So 2 is greater than that of 1, right? So we will now, so that's why this else part will be true and right max will be updated. So right max will be updated with 1, and so we will update the answer also. So right max value is what? 1. Right max value is what? 1, and 1 minus height of right x. So what it is? 1 minus 1. So 0 only, nothing, no water is going to be stored. Right value will be reduced. So this time right is pointing to this 2. And left is also pointing to this 2. So 2 and 2 values similar, right? So in that case, this if condition is going to be true. And left max we are going to calculate. So left max is going to be what? 2 this time, because this is the maximum value, right? And answer we are going to update. So left max is what? 2. And height is what? Height is what? 2 also, 2 only. So no water is going to be stored. So answer will remain as it is. The value was what? 1. So 1, and left value we are going to increase. So this time left value is going to point to 1. So this is how it will continue, right? So you got the logic, right? So this is how it will continue. We will continue with our iteration, and that's how we will get, okay, what unit of water is being stored, right? And at the end we are going to simply return the answer, which in this particular test case is going to be 6, right? So yeah, this was the problem, a very important problem I would say, and has been asked, like even I myself have encountered the similar problem with no changes. The same problem they will give you, trapping rainwater, to solve during the interview. So make sure that you are solving this problem, and a very good problem to get a better understanding on two-pointer approach. So thank you so much for watching this video, everyone. Bye bye.